Let's practice understanding the commutative, associative, and identity properties better together. For these first set of practice problems, we're just going to go ahead and state which algebraic property is shown in each example. We don't need to solve anything. For number 1, we have this numerical expression where we're adding 15 and 9 or finding the sum, and then you can notice here that we have 9 plus 15. So since the order changed here from 15 to 9, 15 first and 9 second, 9 first and 15 second, we would go ahead and say that this represents the commutative property of addition. For number 2, we have the quantity of 9 plus 8 plus 2 afterwards, and that's equal to 9 plus the quantity of 8 plus 2. Notice in this practice problem that we have the grouping around the 9 and 8 first, and then we have the grouping around the 8 and 2. So notice how it moved from the 9 and 8 over to being around the 8 and 2, so the grouping changed. Now, while the grouping changed, notice how the order of the numbers didn't change at all. If the order changed, it would have been commutative property as well, but just because the grouping changed, we'll say here that this represents the associative property of addition. For number 3, we have this expression on the left side of negative 5 plus 0, and on the right side that's just equal to this negative 5. Now keep in mind what happens when you just add 0 to something. 0 is the only number in the world you can add to another value so that the value of the original number does not change. When you add 0 to something and it doesn't change, that represents the identity property of addition. For number 4, we have the product of 8 and 7, or 8 times 7, is equal to the product of 7 times 8. So just like earlier where we had addition and we changed the order, notice how this is multiplication, but the order changed. So it's still the commutative property, but more specifically, it's the commutative property of multiplication. Here's number 5. For number 5, it looks like we have 8 times the quantity of the product of 5 and 7, or 5 times 7, and that's equal to the quantity of 8 times 5, and then multiplied by 7 afterwards. So notice here, the order of the numbers stays the same. We have 8, 5, and 7, 8, 5, and 7. So it's important to know here that the grouping changed, but the order stayed the same. Since just the grouping of the multiplication sentence changed, this represents the associative property of multiplication. For number 6, we have the expression negative 5 times 1, or the product of negative 5 and 1, and that's just equal to negative 5. Now, notice there's 1 here. 1's the only number in the world that you can multiply a number by, and it stays the same. So similar to how we have the identity property of addition, where you can add 0 to something and it stays the same, this represents the identity property of multiplication, where if you multiply anything by 1, it just stays the same. Here's number 7. For number 7, we have the expression x plus y is equal to y plus x. So it's actually very similar to number 1 over here, where we had 15 plus 9 equals 9 plus 15. We just have two unknowns here. Basically, even though we have variables here, this still represents the commutative property of addition, where you change the order of an addition problem. For number 8, we have the product of 1 and x, or 1 times x, and that's just equal to x. So this one's similar to another one we just did a moment ago, where if you multiply anything by 1, it stays the same, even if we don't know what it is, like x in this case. So we can say here that this represents the identity property of multiplication, where you can multiply anything by 1 and it stays the same. For number 9, we have x times the quantity of y times z is equal to the quantity of x times y, then multiplied by z. So notice how the grouping here is this yz, and then the grouping moves over to this xy that's being multiplied. So the grouping was around the second two factors here, and now the grouping is around the first two factors. So the grouping changed here. If the grouping changed and we're dealing with multiplication here, this represents the associative property of multiplication. Let's check out number 10. For number 10, we have the expression x plus 0 on the left side, or the sum of x and 0, and that's equal to x, which is on the right side. Now, if we're going ahead and adding 0 to something, remember what happens, that just stays the same. Since 0 is the only number in the world you can add to another value where it then stays the same, we can say that this expression here represents the identity property of addition, where you can add 0 to something and it stays the same. For number 11, we have the quantity of x plus y, or the quantity of the sum of x and y, then adding z afterwards, and that's equal to x plus the quantity of the sum of y and z. Notice how the order of x, y, and z stays the same order as x, y, and z, but we can see the difference here is that the grouping is adding the x and y first, and then this on the right side, we're adding y plus z first. So notice the grouping moved from this over here in the beginning to over here towards the end, where you're adding the second two addends as opposed to the first two addends. If we're dealing with addition and the grouping changed, this must represent the associative property of addition. Finally, for number 12, we have the product of x and y, or x times y, is equal to y times x, or the product of y and x. Notice here we don't have any parentheses. It's not like we're adding 0 or multiplying by 1, but we can see here that the order of the multiplication problem changed. If we're dealing with multiplication and the order changed, then we can say here that this represents the commutative property of multiplication. Let's try some more practice problems here. For these practice problems, we're going to go ahead and evaluate each of the following numerical expressions. Evaluate just means that we're going to go ahead and solve them. Now, on top of evaluating or solving these numerical expressions, we need to also go ahead and state at least one algebraic property that we use to evaluate each expression. So for number 13, we have the sum of -5 and +5 and +8, so we're adding these all together. Now, if we're going to go ahead and do this, we really should just add these first two numbers together, this -5 plus 5. Now, -5 plus 5, since they're opposites, they're going to add to 0, right? So we're going to have 0 plus 8. Now, if 0 plus 8 is just equal to 8, that's actually what this value of this expression is going to be equal to. Now, since we added 0 to 8 and it stayed the same, we can say that we use the identity property of addition here. We couldn't have used the commutative property because we did not change the order of anything here, and we did not use the associative property because we did not change the grouping of anything either. Here's number 14. For number 14, we have the quantity of the product of 9 and 5, then multiplying that by 4. Now, to multiply these, I think what I'd like to do here, to multiply a little bit more efficiently, is multiply this 5 and 4 first together instead of the 9 and 5. That being said, if we originally have 9 and 5 grouped together, if we leave this 9 outside by itself and then move the grouping so we have 5 times 4 instead here, notice what's going to happen. We would multiply 5 times 4 first together here. 5 times 4, that's going to equal 20. And then 9 times 20, that's going to equal 180. So the value of this expression is equal to 180. So we started off with the parentheses around the 9 and 5, and we moved them so they're around the 5 and 4. If we went ahead and changed the grouping of the multiplication, we must have used the associative property of multiplication. Alright, so for number 15, we have this 0.25 multiplied by 9 multiplied by 4. So what's the most optimal or efficient way of multiplying these three numbers mentally? Well, we have a decimal of 0.25, which is a quarter, and we're multiplying that maybe by 4 would equal 1, and that's a pretty nice number here. So if we want to do that, we want to remember here that by default, if we're multiplying three numbers together, that technically the grouping is right around the first two factors, right? It's always at the beginning from left to right. So what I would do first is change the order of what's inside the brackets or parentheses or grouping symbols here. So it's 9 multiplied by 0.25. Let's go ahead and just change the order of those two factors inside of there. And we're going to have this multiplied by 4 on the outside. So we just changed the order, and hopefully that makes sense that we changed the order there, that we use the commutative property of multiplication. Now, what if we want to go ahead and multiply that 0.25 times 4? Well, that 9's then going to have to be left on the outside, and we're going to change the grouping here. So it's going to be that 0.25 and multiply that by 4. So the 4 is now inside the grouping symbol here. Okay, now what is this 0.25 times 4? Well, we know a quarter times 4 hopefully is 1. So this is going to be 9 times 1, and 9 times 1 is going to be 9. So the value of this expression is equal to 9. So which algebraic properties did we use here? We technically used all three properties of multiplication that we've been discussing in this problem. So when we went ahead and changed the order of the 0.25 times 9 and changed it to 9 times 0.25, we used the commutative property of multiplication because we changed the order. Now, when we went ahead and changed the grouping around this 9 times 0.25 and moved the grouping to the 0.25 times 4, we actually used the associative property of multiplication where you change the grouping. Finally, when we have this 9 times 1 at the end here, and we said 9 times 1 is just equal to 9, when you multiply anything by 1 and it stays the same and it gets you 9, we must be using the identity property of multiplication. While the directions say write at least one algebraic property, these would be all three that you could have used or written down for this particular problem. Let's check out number 16. For number 16, it looks like we have a bunch of add-ins here. We are adding 7 plus 9 plus -7. So by default, what would we be adding together first? Well, by default, we'd have to be adding the first two add-ins together, right? That's always the default if we're having all addition here. So we can go ahead and say that we can group this 7 and 9 at the beginning because that's where it is by default. Now, what would we like to add together? I think we'd like to add this 7 and -7 together because that would be a nice 0. So how are we going to get the 7 and negative 7 next to each other? Well, first, let's go ahead and just switch the order of these two addends inside of this grouping symbol. So let's go ahead and write this 9 first, and let's go ahead and add the 7 second. Okay, so now you can see the 7 is in the middle, but the 9 is onto the left. And we're going to go ahead and add this negative 7 on the outside. Okay, so what we did there is we just switched the order, and so we used the commutative property of addition. Now, again, we'd like to go ahead and add this 7 and negative 7 together, right? But right now they are not in the same grouping. So let's go ahead and leave the 9 on the outside here and change this grouping. So instead of the 9 and 7 inside there, we would have 7 plus negative 7, and that would be in the parentheses now. Okay, so notice here that we have 7 plus negative 7. We just changed the grouping, right? So the grouping was around this 9 and 7. You could use parentheses, you can use brackets, but then we moved this brackets or parentheses around the 9 and 7 to around the 7 and negative 7. So that's the associative property of addition. Now, what is 7 plus negative 7? That is equal to 0 because they're opposites. Now, 9 plus 0 is just equal to 9. Since 9 plus 0 is equal to 9, then we must have used the identity property of addition. All right, so what properties did we use here, right? Now notice here at the beginning, we took this 7 plus 9 and we changed the order to 9 plus 7. When you change the order, that's the commutative property, and we're adding here, so it's of addition. Then next what we did was we took the grouping around the 9 and 7, and we moved it to group the 7 and negative 7 because we wanted to add those together. That's the associative property of addition. And finally, when you took 9 plus 0 and you still got 9, that represents the identity property of addition. Let's try number 17. For number 17, we have 0.1 or 1/10 multiplied by 6.38 or 6 38/100 multiplied by 10. Now, the most optimal two numbers to multiply together here I think are going to be 0.1 and 10, just because 0.1 is a tenth, and a tenth times 10 is just equal to 1, which is a nice number here. So remember, what do we have to multiply first by default? Well, by default, we have to go left to right if it's all multiplication. So we have to put the grouping symbol here, and we'd like to multiply that 0.1 by 10. So let's go ahead first and just switch the order of these two because they're both inside, so we can do that. That's where we have to look first. So we change the order. It's going to be 6 38/100 multiplied by 1/10. That's actually going to go what we're writing and write the order of it differently. So let's go ahead and now switch the order here of what's inside the grouping symbol, because you can switch the order as long as it's what we're looking at first, and that's what's inside the grouping symbol. So we have 6.38 first, and let's multiply that by 0.1. So we just change the order. That's the commutative property of multiplication, and then we're going to multiply that by 10 afterwards. Now keep in mind, we'd like to multiply the 0.1 by 10, but right now we can't because they're not grouped together. But we can change that by using the associative property. And so let's leave this 6.38 outside, okay, and regroup here. So let's go ahead and say that we're going to multiply by 0.1 and multiply that by 10. Okay, so we're going ahead and changing the grouping here. So we did have the grouping over here, and we moved it, but we didn't change the order of any numbers. So that's the associative property of multiplication. Now 0.1 times 10, that's going to equal just 1. So it's 6.38 just multiplied by 1, and that's going to equal 6.38, right? Multiplying anything by 1 stays the same, so that is the identity property of multiplication. So let's recap what properties we used here. We changed the order of the multiplication, so that's the commutative property of multiplication. We then went ahead and moved the grouping from over here to over here. So we changed the grouping, but we didn't change the order. That's the associative property of multiplication. And then finally, anything times 1 stays the same. That's the identity property of multiplication. For number 18, we have the product of 7 times 2 in parentheses multiplied by 5 afterwards. So that's the quantity of 7 times 2, then multiplied by 5. And so how are we going to go ahead and multiply these? Well, 7 times 2 is 14, right? Now 14 times 5, that's not terribly difficult, but I think it's a little bit easier if we could multiply 2 times 5 in our head first. That would be 10, and 10 times 7 would be 70, which would be kind of nice for us, right? So let's go ahead and see if we can multiply those together instead. So I think what we do here is, let's go ahead and see if we can regroup the parentheses. So instead of grouping the 7 and the 2 together, let's go ahead and multiply and group. So we have the 2 times 5 multiplying together instead. So let's move the 2 times 5 together in the same grouping symbol. And then now we have them together, which is an easier multiplication problem. Now, if we just move the parentheses or the grouping, we just use the associative property of multiplication. Now we can just go ahead and multiply 7 times 10. 2 times 5 is equal to 10. And then 7 times 10 is equal to 70. So that's the value of this expression. I think I forgot to write the value up here. I'm going to write 6.38 just so it's consistent. So for this given expression, all we really did was move the parentheses or the grouping around the 7 and 2, and we moved around the 2 and the 5. So that represents the associative property of multiplication, right? We didn't change the order of anything, so we didn't use commutative property. We also didn't multiply by 1, so we couldn't have used the identity property. All right, let's check out number 19. Oh, I noticed for number 16, I never wrote the answer next to the equal sign either. Not a big deal, but I'm just going to put that over there now. Okay. Okay, so for number 19, looks like we have multiplication again. We have the product of 17 times the quantity of 0.5 times 2. Okay, so there's two sets of parentheses here. If that's a little confusing, we can change this one over here to brackets. So you can see that those are actually kind of grouped together right now. So that's important to know. Now, what would be the most optimal thing to multiply together here? Do we want to multiply 0.5 over here by 17? I don't think so because it's an odd number. Do we want to multiply 2 times 17? I don't think so. I think we actually really like this 2 times this half here because half of 2 is just equal to 1. So let's not go ahead and change the order of anything. Let's just keep this because that's kind of nice already, right? So half of 2 is going to be 1, or half times 2 is 1. So we have 17 times 1, and 17 times 1 is just equal to 17. So for this particular problem, it looks like what we wanted to multiply, or the most efficient thing to multiply together first, were already grouped together, so we didn't have to change any groupings, and we didn't have to change anything in the order, which is really nice. But when we went ahead and just multiplied 17 times 1, multiplying that by 1 and having it stay the same, that's the identity property of multiplication. Alrighty, for one final expression for number 20, we have 3 addends here. We have negative 18 plus 39 plus 18. Now, if you think you should be adding this negative 18 and positive 18, I think that's the best choice here because they're going to get you 0, right? Now, what would we have to add together first by default? By default, we'd have to start here and add negative 18 plus 39, moving from left to right. But if we want to go ahead and add negative 18 and 18 together, we have to get them next to each other inside the parentheses. So let's go ahead and start by swapping these two, changing the order here. If we change the order, again, we're going to go ahead and have here 39 plus negative 18, right? So the order is swapping here. If we go ahead and swap the order, then we can go ahead and just keep that plus 18 the same on the outside. Now, you can notice here that this negative 18 and 18 are closer to each other now, but the order changed, so we use the commutative property of addition. Now, how are we going to get this negative 18 and positive 18 together? Well, we have to change the grouping. So 39 has to be left out here by itself. Sorry, 39. And then what's going to happen inside here is we're going to regroup and have negative 18 plus a positive 18. So these two are now going to be grouped together, which is really nice, but that's the associative property, right? So we went ahead and changed the grouping from the first two to the second two addends here. Now, what's negative 18 plus 18? That's equal to 0, so that's going to be 39 plus 0. And 39 plus 0 is just equal to 39, so that's going to be the value of this expression. Now, what was really going on behind the scenes to help us get this answer of 39 efficiently? All right, well, first of all, we used the commutative property of addition when we went ahead and took this negative 18 plus 39 and changed the order to 39 plus negative 18. Okay. After that, what did we do? Well, we moved the grouping symbol around the 39 and negative 18, and we regrouped, so it was negative 18 plus 18. We didn't change the order, though, so that's the associative property of addition. And then finally, what did we do? We took this 39 and we added nothing to it, so it stayed as 39. And mathematically, we say we use the identity property of addition. So there you have 20 different practice problems dealing with using these 3 algebraic properties of the commutative property, associative property, and identity property. Again, all these problems, sure, you could just go left to right, but we're trying to think a little bit more on a higher level where we can understand why we can make good decisions in solving these problems more efficiently and optimally, so we can go a little bit faster and more efficiently. So if you found this video helpful in understanding these properties, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.